Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. Good evening, Mr. Muhammad Iksan. So today we are from Group 4 and we're going to presentation about case study assignment. It is about renewable energy grid management. Okay, first thing first, we would like to introduce ourselves. First is Amanda Kirana Sari, second Dita Nugraheni, third Mutia Kintar, and lastly, myself is Safira Azahra. So first, I would like to presentation about case analysis and summary. Okay, case summary. The power grid that combines renewable energy like solar and wind and traditional energy faces the challenge of supply and demand imbalance due to weather changes. Computational solutions are needed to predict energy production based on weather data, balance power distribution in real time, and optimize energy storage in batteries. With the right algorithm, the system can reduce dependence on non-renewable energy, improve grid efficiency, and ensure sustainability electricity supply stability. And my name is Safira Zahra, and this is the pillars of computational thinking about decomposition. First is analyze weather patterns and their impact on renewable energy production, and then identify factors that affect the balance of energy supply and demand. And last but not least, it is determine energy storage needs and excess energy utilization options, and then assess dependence on non-renewable energy sources.
It's Mutia Kintar, and I'd like to explain about the pillars of computational thinking, firstly, in pattern recognition. And now the second pillar of computational thinking is pattern recognition, which focuses on identifying trends and regularities that can help solve problems. In renewable energy, it is used to analyze historical weather data trends and allows us to recognize how past weather conditions affected energy production. And the second one is to recognize factors that cause power imbalances in the electricity grid. And the last one is to determine optimal strategies for energy storage and distribution in real time. It is made easier by recognizing consumption patterns. Next. Next slide.
Okay, my name is Dita Nugraheni, and now I would like to explain about the algorithm design in the pillars of computational thinking.
The next one is abstraction. It is used to simplify energy production prediction using key weather data such as wind speed and solar intensity. Next, it's to determine key factors affecting energy consumption in different regions. And the last one is to create optimal models for energy allocation and storage based on supply and demand trends. Next slide.
So I would like to explain about the algorithm design. So first, we use the predictive algorithm to project renewable energy production based on weather data. And by analyzing historical patterns and real-time inputs, this algorithm helps us anticipating energy generation and optimize its usage. And second, we apply real-time balancing methods to adjust energy distribution, which can ensure that supply meets demand efficiently and prevent wastage or shortage. And next, we design energy storage algorithm that consider battery capacity and future power needs. And this can help in making smart decisions about when to store and release energy, which can maximize efficiency. And lastly, we can use either a greedy or brute force approach to optimize energy distribution. Well, a greedy approach make the best immediate decision at each step, while a brute force method explores all possible options to find the best solutions. Next, we now I will walk you through this flow chart, which we can begin with the start stage where the system is set in motion to collect data and make informed decisions about energy distribution. And then the first step is by collecting the data, and this includes weather forecast, energy consumption patterns, and battery levels to understand the current energy landscape. And then next, we use the predictive model to estimate future energy production and consumption. And this can help uh, making proactive decisions about like energy allocations. And then after predictions are made, we analyze the data to identify potential supply demand gaps and determine the best course of action. And next, at this decision point, we compare the predicted energy supply with the expected demand, and based on the result, we can take different actions. Well, if the supply exceeds the demand, we store the excess energy in batteries or switch to another network to prevent waste. And if the demand exceeds the supply, we can take the energy from stored batteries or as a last resort, use non-renewable energy sources. And next, after balancing supply and demand, we optimize storage and distribution to ensure energy is allocated efficiently. And next, as energy needs to fluctuate, strategies are adjusted in real time to maintain a stable and sustainable energy flow. And then the ultimate goal is to reduce reliance on non-renewable energy by maximizing the efficiency of renewable energy sources. And lastly, the process concludes, but this is a continuous cycle, so it can ensure an ongoing energy optimization. Next.
My name is Amanda Giranasari, and I would like to explain about the pseudocode and big O notation. This pseudocode outlines an energy distribution system that predicts renewable energy production, calculates demand, and manages battery storage. If production exceeds demand, excess energy is stored, otherwise, stored energy is used. If the battery is empty, the system resorts to non-renewable energy, ensuring efficient and sustainable energy use. Next. The algorithm has a time complexity of O(n), meaning processing time increases quadratically with more weather and energy data. This poses scalability challenges requiring future optimizations like data reduction or parallel computing to improve efficiency and adaptability. So we can conclude that this system optimizes energy use by balancing renewable production, demand, and storage. While effective, its O(n) complexity requires optimization for scalability. Future improvements can enhance efficiency, making energy management smarter and more sustainable. That's all for our presentation. Thank you so much for listening. Wassalamualaikum warahmatullahi wabarakatuh.